Okay, so for this example, we're going to sketch two periods. I just want to make sure that you're comfortable with this notion of what it means to sketch two periods of a function of y is equal to -1/2 cosine of 3x. So the first thing that we should notice is that there's going to be a change in amplitude, and that's what that -1/2 means over there. So the amplitude is the absolute value of that number in front of the function that's stuck to the sine or cosine. And so we have an amplitude of the absolute value of -1/2, which means 1/2. So instead of maxing and minning out normally at 1 and -1 for sine and cosine, now we're going to max and min out at 1/2. I'm just going to put this over here. This is 1/2, and we're going to min out at -1/2 for our cosine function. So that's the first thing that we need to keep in mind. Now let's talk about what the negative means. And so remember, anytime we multiply the outside of a function by a negative, then we're going to reflect the function over the x-axis. So we have a vertical shrink by a factor of 1/2. That's what that amplitude of 1/2 means. And we're going to reflect our function over the x-axis. So normally we know that cosine would start up here, come down, and then come back up again. Now cosine's going to start at -1/2, come up, and then come back down again for one complete period. Well, now let's talk about what the period of the function is. So notice that we have a 3 that's stuck in front of our argument in front of the x over here. That means that there's going to be a change in our period as well. So the normal period is 2 pi, but now because we have a number in front of our function, now our period's going to be 2 pi over 3. Okay, so that means instead of doing one complete cycle from 0 to 2 pi, now we're doing one complete cycle starting at 0 and ending at 2 pi over 3. All right, so we know what our period is. So we're going to end right over here, one complete period at 2 pi over 3. And then we're going to talk about what it means for two complete periods. So think about it, for 2 pi over 3, two complete periods of it means you're just going to, if you're starting here at 0 and ending at 2 pi over 3, you're going to add 2 pi over 3 to itself. And that means we're going to stretch this to 4 pi over 3. And 2 pi over 3 plus 2 pi over 3 is 4 pi over 3. Now, in between here are our critical values. And remember, for each function, for sine and cosine, I want to see 5 critical values. We have 2 of them. We have a beginning and we have an end, but we're missing these 3 critical values in the middle, and we're going to do these here as well, these 3 critical values in the middle. So let's discuss how to find them. So again, in order for us to find our critical values, and by the way, that's just a word that I use. Not all textbooks use that language of critical values, but they represent the maximum, minimum, and zeros of the functions. We're going to take our period, which is 2 pi over 3, and we're going to divide that by 4. And this is always a general rule. You want to take whatever your period is and divide it by 4. So 2 pi over 3 divided by 4 is the same thing as saying 2 pi over 3 times 1/4, which is 2 pi over 12. And if we simplify that, instead of 2 pi over 12, we get pi over 6. What that means is we're going to have intervals of pi over 6. So we're going to start over here at 0, and then we're going to add pi over 6 to it. So pi over 6. And then we're going to start at pi over 6 and add pi over 6 to that again. We get 2 pi over 6. If we reduce that, 2 goes into 6 3 times, we have pi over 3. Or 2 pi over 6. So I'll write that on here. Now, if we have 2 pi over 6, which as we know is equivalent to pi over 3, and if we add pi over 6 to that again, then that's going to give us 3 pi over 6. And if we simplify that, hopefully you can see we get pi over 2. And if we add pi over 6 to that again, we're going to get 4 pi over 6. And if we simplify that, we're going to end right here, which is at 2 pi over 3. So there's our one complete period. But we can continue with that. So again, because I wanted to do 2 complete periods, I'm going to continuously add pi over 6 until I get to that 4 pi over 3. So this is 2 pi over 3. Remember, that's the same thing as saying 4 pi over 6. Let's add pi over 6 to that again. That gives us 5 pi over 6. Let's add pi over 6 to that again. Move up a little bit over here. And that gives us 6 pi over 6, which is the same thing as saying pi. So we have 6 pi over 6, and we're going to do something called pi. Let's add pi over 6 again. That's going to give us 7 pi over 6. And let's add pi over 6 one more time. So that's 7 pi over 6. We add pi over 6 again. Then that's going to give us 8 pi over 6. And if we reduce 8 pi over 6, we get 4 pi over 3. So we ended up exactly where we thought we would. We have all the critical values we need for these 2 periods. Let's remember where cosine normally starts. Again, cosine, and let's do that in blue. Cosine normally starts up here At 1 goes down, comes back around again. But again, because we have a negative in front of the function, instead of starting at 1, we're going to start at -1. And because we have the 1/2, instead of starting at +1/2, we're going to start at -1/2. And if you just remember the shape of the function, that's all you need to know. It's going to hit all of those critical values that we just talked about. So here is 1 complete period, and we're going to continue with that. Here are 2 complete periods. And this, again, remember that it will go infinitely to the right and infinitely to the left as well, but here are just some of the critical values that are associated with it. Notice again for cosine, we're going to have 2 min and a max, and we're going to have 2 zeros. Normally we have 2 max and a min, but because it's a reflection, now we're going to have 2 min and a max.